This problem is a series that involves factorials. So this is a beautiful example where we'll be using the ratio test. Okay, so again, the series is sigma from n equal 1 to infinity n factorial to n factorial and 3n plus 1 factorial. So we are going to use the ratio test. Okay, so for that, let us call this an. So an is equal to factorial n factorial 2n over 3n plus 1 factorial. So now we need to come up with an plus 1, and this is a typical mistakes that students will be doing, which is that they will replace n by by n plus 1. So I always tell people to replace n by n plus 1 parentheses. It's very important. N, whenever you see n, put n plus 1 between parentheses. Otherwise, you will be doing mistakes like 3n gives 3n plus 1, okay, which is wrong. And 2n becomes 2n plus 1, which is also wrong. So if you put the parentheses, you will avoid mistakes. Okay, so we have n plus 1 factorial 2 times n plus 1 factorial over 3 times n plus 1 plus 1 factorial. So an plus 1 equal, and now we go n plus 1 factorial 2 times n plus 1, that's 2n plus 2 factorial, and 3n plus 1, that's 3n plus 3 plus 1 factorial, which gives us an plus 1 equal n plus 1 factorial 2n plus 2 factorial and 3n plus 4 factorial. Okay, as you can see, mostly is algebra before we proceed to find the limit and then apply the ratio test. So now we go for an plus 1 divided by an. So we have the top fraction, which is n plus 1 factorial, 2n plus 2 factorial, 3n plus 4 factorial, and an is n factorial 2n factorial divided by 3n plus 1 factorial. So we have fraction over a fraction. We know that it's going to be the top fraction. So again, an plus 1 divided by an equal the top fraction, which is an plus 1, n plus 1 factorial to n plus 2 factorial over 3n plus 4 factorial times the inverse of the bottom fraction, 3n plus 1 factorial over n factorial to n factorial. So now we need to reorganize this. So imagine all these calculations are purely algebraic calculations before even you get into the limits, okay? So now what we are going to do, we're going to put terms together so we can simplify them. So for example, we are going to put the 3n plus 1 above 3n plus 4, okay? And the 2n plus 2 over the 2n factorial, and the last one is n plus. So we get an plus 1, so we are able to do some algebra over an equal. So we have n plus 1 factorial over n factorial. And then we have 2n plus 2 factorial over 2n factorial. And finally, 3n plus 1 factorial over 3n plus 4 factorial. So this will give me, and now we have to use the properties, the algebraic properties of the factorials. So we know that n plus 1 factorial, that's n factorial n plus 1 over n factorial. To n plus 2, we need to go down to 2n, so we get 2n factorial to n plus 1 to n plus 2 over 2n factorial. And finally, we have 3n plus 1 factorial over 3n plus 1 factorial. And then you have 3n plus 2. So here, I'm going to need some space. So we have 3n plus 2, 3n plus 3, and 3n plus 4. Okay? So now we cancel. So we cancel the factorial here, 2n with 2n, and this one with this one, to stay with. So we have an plus 1 over an equal n plus 1 to n plus 1 to n plus 2 over 3n plus 2, 3n plus 3, and 3n plus 4. So now we look at for the limit, and since we're looking at the limit when n goes to infinity of an plus 1 over an, so what we do, we only keep the highest power. So we keep this one with this one with this one, and this one with this one with this one, okay? Because this is a rational expression in powers of n, so this will give me limit when n goes to infinity of n times 2n times 2n over 3n times 3n times 3n. So we say that we have 4n cubed at the top and 27n cubed at the bottom. So the limit is, once we cancel the n cubed, we get 4 over 27. And since 4 over 27 is less than 1, we conclude that our original series is convergent by the ratio test.